We're now going to talk about part 2 of our detailed coverage of Java Lambda expressions. In this part of the lesson, we'll first discuss some of the benefits of applying Java Lambda expressions in practice using a concrete example. And then we'll also show how to implement a language feature called closures using Java Lambda expressions. Lambda expressions can work with multiple parameters in a much more compact manner than using anonymous inner classes, which is an alternative way of doing things in earlier versions of Java. For example, here we're going to define ourselves a local variable called nameArray, which is an array of strings representing different names. And then we're going to go ahead and sort that array with a couple of different approaches. The first approach we're going to use is using traditional anonymous inner classes. What we're going to do is we're going to call the arrays sort method, passing in the nameArray, and then an anonymous inner class instance, which, as you can see, is very verbose and very extravagant syntax. A lot of ceremony going on here, as they like to say. We say new comparator, we then say public int compare, string s, string t, and then finally we get to the meat of the actual computational logic, which is going to lowercase each of the string parameters and then use the compare to method to see if they're equal or not. We can do a lot better than this. What we're going to do instead is the second example is we're going to use a Lambda expression that takes two parameters. As you can see here, we once again call arrays.sort, passing in the nameArray, but then we go ahead and have some extra concise syntax. It's very lean and mean. We say open paren s comma t, which is essentially shorthand for string s, string t, thereby leveraging modern Java's type inference capabilities that you'll find with modern Java compilers. And then we go ahead and have the arrow, which is just the syntax saying we're going from the parameter list to the body of the Lambda. And in the body of the Lambda, it's very concise. We just say s.compare to ignore case t. So really, really concise, really to the point. Much more easy to understand once you understand how to read the Lambda expression syntax. Another thing to note here, I mentioned earlier that Lambdas are unnamed blocks of code. Well, that's exactly what we see here. This Lambda expression omits the name of the method. It's just the computation to perform and all the other extraneous syntax that was provided by the very verbose anonymous inner class. So it's really stripped down. Therefore, as a rule of thumb, it's good practice to try to use Lambda expressions whenever you can. And in fact, in modern interactive development environments, such as IntelliJ or Eclipse and so on, they actually have features that will automatically transition and convert anonymous inner class representations of code to Lambda expression representation when it can do that transition and conversion automatically. So keep an eye out for that in your IDE. Let's now transition to talking about how to implement closures using Java Lambda expressions. A Lambda expression can be used to implement a simplified variant of a language feature called a closure. And a closure is essentially a persistent scope that holds on to local variables and their state even after the code execution has moved out of that block or out of that scope. So let's take a look at an example. You can find this example in the link at the bottom of this slide in my GitHub repository. And just to be real simple, it's called closure example. So the first thing I'm going to focus on here is the closure portion. And so a closure in modern Java using Lambda expressions is an object that stores a method together with an environment that has at least one bound variable. And a bound variable is just a name that's associated with a value, such as a number or a string. So you can see here, we're focusing on the part that's in red, and that's the new thread, which is creating a thread, and then the Lambda expression that's passed into it. And it's going to go ahead and print out some information based on parameters and a local private variable, which we'll talk about in just a second. In this particular example, the private field mres, which is a private int, is a bound variable, as are the parameters to the make thread closure method, string s and int n. Those are the three bound variables in this context. And you can see how those bound variables are actually being used in the context of what's passed as a Lambda expression to the constructor of thread. The Lambda that's passed to the constructor of thread captures this private field, mres, and the two method parameters. Now, there's some interesting constraints on this. Values of private fields like mres can be updated in a Lambda. So they can be accessed, they can be read from, and they can also be updated. They can be written to. However, parameters and local variables cannot be updated. They can only be accessed. You can only read them. They're read-only. And that's something important to keep in mind. And that's one thing that makes the variants of closures that are provided with Java Lambda expressions a little bit different from a full-blown language that supports closures. Make thread closure, of course, is a factory method in the sense of the good old gang of four factory method pattern that you're most likely familiar with that creates the closure. And then down here in the constructor for closure example, you can see how we use it. We call make thread closure, passing in the string result equal and passing in the initial value n. And then if you look at what's happening inside that thread, that will go ahead and create a background thread. And we'll get that back as thread t as a local variable. And then this particular constructor says t.start, which will start the thread. And once the thread starts, it'll go ahead and print out result equal, and then it'll take mres and plus equal n. So it'll basically say result equal 10. But it'll have the side effect of updating the local field, the private field, int mres, to have the value of 10. So that concludes the second part of our discussion of Java Lambda expressions. As you can see, there's some good benefits that they provide, especially in terms of making code more concise and more compact. And you could also use them to implement variants of very interesting programming language features, such as closures.